Hello. Welcome back to our channel, where we explore the latest developments in science and technology. Today, we're going to talk about the Indian Space Research Organization's, ISRO, X-ray Polarimeter Satellite, also known as XPoSat. In this video, we'll explore what XPoSat is, what it will do, and why it's important. XPoSat, X-ray Polarimeter Satellite, is India's first dedicated polarimetry mission to study various dynamics of bright astronomical X-ray sources in extreme conditions. The spacecraft will carry two scientific payloads in a low Earth orbit. The primary payload POLIX, polarimeter instrument in X-rays, will measure the polarimetry parameters, degree and angle of polarization, in medium X-ray energy range of 8 to 30 keV photons of astronomical origin. The XSPECT, X-ray spectroscopy and timing, payload will give spectroscopic information in the energy range of 0.8 to 15 keV. The emission mechanism from various astronomical sources such as black hole, neutron stars, active galactic nuclei, pulsar wind nebulae etc. originates from complex physical processes and are challenging to understand. While the spectroscopic and timing information by various space-based observatories provide a wealth of information, the exact nature of the emission from such sources still poses deeper challenges to astronomers. The polarimetry measurements add two more dimensions to our understanding: the degree of polarization and the angle of polarization. Thus is an excellent diagnostic tool to understand the emission processes from astronomical sources. The polarimetric observations along with spectroscopic measurements are expected to break the degeneracy of various theoretical models of astronomical emission processes. This would be the major direction of research from XPoSat by Indian science community. XPoSat payloads. POLIX. POLIX is an X-ray polarimeter for astronomical observations in the energy band of 8 to 30 keV. The payload is being developed by Raman Research Institute, RRI, Bangalore in collaboration with ISRO Satellite Center, URSC. The instrument is made of a collimator, a scatterer and 4 X-ray proportional counterdetectors that surrounds the scatterer. The scatterer is made of low atomic mass material which causes anisotropic Thomson scattering of incoming polarized X-rays. The collimator restricts the field of view to 3° x 3°, so as to have only one bright source in the field of view for most observations. POLIX is expected to observe about 40 bright astronomical sources of different categories during the planned lifetime of XPoSat mission of about 5 years. This is the first payload in the medium X-ray energy band dedicated for polarimetry measurements. XSPECT. XSPECT is an X-ray spectroscopy and timing payload onboard XPoSat, which can provide fast timing and good spectroscopic resolution in soft X-rays. Taking advantage of the long-duration observations required by POLIX to measure X-ray polarization, XSPECT can provide long-term monitoring of spectral state changes in continuum emission, changes in their line flux and profile, simultaneous long-term temporal monitoring of soft X-ray emission in the X-ray energy range 0.8 to 15 keV. An array of swept charge devices, SCDs, provide an effective area greater than 30 square centimeters at 6 keV with energy resolution better than 200 electron volts at 6 keV. Passive collimators are used to reduce the background by narrowing the field of view of XSPECT. XSPECT would observe several types of sources viz. X-ray pulsars, black hole binaries, low magnetic field neutron star, NS, in LMXBs, AGNs and magnetars. The XPoSat satellite is a small satellite designed to study the polarization of X-rays emitted by celestial objects. The satellite was developed by ISRO in collaboration with the Raman Research Institute and the Tata Institute of Fundamental Research. Scientist, engineer, XPoSat is a unique satellite, as it will be the first space mission to study the polarization of X-rays. The polarization of X-rays can provide us with valuable information about the properties of celestial objects, such as black holes, neutron stars, and supernovae. Host XPoSat is equipped with two main instruments, the X-ray Polarimeter Instrument, XPI, and the Scanning Sky Monitor, SSM. The XPI is designed to measure the polarization of X-rays, while the SSM will monitor the X-ray sky for transient events. Scientist, engineer. The XPI instrument is based on a novel technology called the gas pixel detector. This detector is capable of measuring the polarization of X-rays with a high degree of accuracy, which is critical for the success of the mission. Host, XPoSat will be launched into a circular orbit around the Earth at an altitude of 500 kilometers. The satellite will operate for a period of 5 years, during which it will collect data on the polarization of X-rays from various celestial objects. Scientist, engineer. One of the main goals of XPoSat is to study the polarization of X-rays emitted by black holes. Black holes are some of the most fascinating objects in the universe, and we still have much to learn about them. By studying the polarization of X-rays, we can learn more about the magnetic fields and accretion processes around black holes. Host. XPoSat's data will be analyzed by a team of scientists and engineers from ISRO, the Raman Research Institute, and the Tata Institute of Fundamental Research. The data collected by XPoSat will be made available to the scientific community for further analysis. Scientist, engineer. XPoSat is an important mission for ISRO, as it will help us develop new technologies and techniques for studying the universe. We are excited to see what we will learn from this mission and how it will help us further our understanding of the universe. Host. And that's a wrap. We hope you enjoyed learning about the ISRO X-ray Polarimeter Satellite mission. Don't forget to like and subscribe to our channel for more updates on the latest developments in science and technology. Thanks for watching.